now, you have learned to find the zeros of a quadratic polynomial. So, you will be knowing polynomials of different degrees. Today, let us learn about division algorithm for polynomials. In lower classes, you have seen this method of checking quotient and remainder, isn't it? This is actually division algorithm. That is, dividend is equal to divisor into quotient plus remainder. Now, let us see what is the division algorithm for polynomials. This is division algorithm for polynomials. When a polynomial p of x is divided by another polynomial g of x, we obtain a quotient q of x and remainder r of x. So, this is division algorithm for polynomials. P of x is the dividend, g of x is the divisor, q of x is the quotient and r of x is the remainder. How to verify division algorithm? First, you will get a polynomial p of x to be divided by the polynomial g of x. After dividing, you will get a quotient and a remainder. With that, you will be asked to verify division algorithm. So first, what should you do? You should multiply divisor and the quotient. Then with that product, you should add the remainder. What will you get? You will get the dividend, that is p of x. This is how you verify division algorithm. Clear? Now, let us see some problems from exercise 2.3. The first question. Divide the polynomial p of x by the polynomial g of x and find the quotient and remainder in each of the following. The first question is p of x is equal to x cube minus 3x square plus 5x minus 3. So p of x is the dividend. Here g of x is equal to x square minus 2. That is, g of x is the divisor. This is the method of dividing two polynomials. X cube minus 3x square plus 5x minus 3 is divided by x square minus 2. Here you can find the quotient as x minus 3. Let's see how you are getting it. The first term in the divisor is x square and the first term in the dividend is x cube. X square into which term gives you x cube? Yes, it's x. X square into x is equal to x cube. So this x we have written here. X into x square minus 2, we get it as x cube minus 2x. Students, here x cube minus 2x, but here you have a x square term. Since you don't have an x square term here, you will put 0x square. So x cube plus 0x square minus 2x. As usual, you will subtract. X cube minus x cube is 0. Minus 3x square minus 0x square is minus 3x square. Plus 5 minus minus 2 is plus 7x minus 3. Here the first term in this remainder is minus 3x square and you are going to divide it by the first term of the divisor. So you will have this minus 3. So here then after multiplying and subtracting you will get the remainder as 7x minus 9. You cannot further divide this 7x minus 9 by x square minus 2. Can you tell me why? Because degree of r of x is less than degree of g of x. You will stop dividing the polynomials when degree of r of x is less than degree of g of x. What is the degree of g of x? It is 2. What is the degree of r of x here? It's 1. So 2 is greater than 1. So you will stop the division here. So the quotient is x minus 3 and remainder is 7x minus 9. Clear? Next one. Question is P of x is equal to x raised to 4 minus 3x square plus 4x plus 5. Here g of x is equal to x square plus 1 minus x. Here you can see that you have some degrees missing here. Exponents missing here. Here cube term is not there. Okay. Instead of cube term, we will write 0x cube. In order to avoid confusion while dividing, you will put 0x cube. Okay. Then here in g of x, you can see that the terms are not in order. So here we first arrange the terms of the dividend and the divisor in the decreasing order of their degrees. Here the first it's 4, then 3, 2, 1, 0. Here we will rearrange it as 2, 1, 0. Okay, degree 2, degree 1, degree 0. Clear? The division is as explained in the before slide. So this is the division algorithm here. Next problem. Second question. Check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first polynomial. Here the first polynomial is t square minus 3. Second polynomial is 2t raised to 4 plus 3t cube minus 2t square minus 9t minus 12. Okay. The division method I have explained in the previous slides. So what is the condition of first polynomial to be a factor of the second polynomial? If a polynomial is a factor of another polynomial, when you divide both the polynomials, you will get the remainder as 0. Clear? If the remainder is 0, the divisor is a factor of the dividend. Clear? If the remainder is 0, divisor is a factor of the dividend. That is the condition of factors. Next one. Obtain all other zeros of 3x raised to 4 plus 6x raised to 3 minus 2x square minus 10x minus 5 if two of its zeros are root 5 by 3 and minus root 5 by 3. Students, this is one of the important questions that comes in exams from this topic. Instead of root 5 by 3 and minus root 5 by 3, it may come root 2 and minus root 2, root 5 and minus root 5, like that. So study the steps very carefully. Since this is a polynomial equation of degree 4, there will be total 4 roots. Here the degree of this polynomial is 4, so you will have 4 roots here. That is 4 zeros here. 2 of the roots are given to you. Root 5 by 3 and minus root 5 by 3 are zeros of polynomial given here. You know, if root 5 by 3 is a 0, you can write the factor as x minus root 5 by 3. If minus root 5 by 3 is a 0, you can write the factor as x plus root 5 by 3. Multiplying this, x minus root 5 by 3 into x plus root 5 by 3. Applying a plus b into a minus b, the answer is x square minus 5 by 3 is equal to 0. As this is a 0, we can equate it to 0. So you will have the factor as 3x square minus 5 is equal to 0. So you got one of the factor of this polynomial as 3x square minus 5. So what will you do? You will divide this polynomial by this factor. Okay. So this is the dividend and this is the divisor. We'll see what happens. 3x square minus 5 is the divisor. 3x raised to 4 plus 6x cube minus 2x square minus 10x minus 5 is the dividend. Following the division algorithm, we will divide it and you got the quotient as x square plus 2x plus 1. This is a quadratic polynomial. You will know that the quadratic polynomial will have two zeros. So you should find the two zeros of that equation. Further factorizing, middle term splitting x square plus x plus 1. Taking x from these two terms, x into x plus 1, and you will get x plus 1 into x plus 1 equal to 0. Equating each of these to 0, you will get x is equal to minus 1 and x is equal to minus 1. Therefore, all four zeros of given polynomial equation are root 5 by 3, minus root 5 by 3, minus 1 and minus 1. All four zeros of the given polynomial. The next type of questions which comes in this topic is dividend, quotient and remainder will be given. Find the divisor. So how will you find the divisor? You should first subtract the remainder from the dividend and from that you will divide that answer by the quotient equal to divisor. This is the type of question. On dividing x cube minus 3x square plus x plus 2 by a polynomial g of x. So your divisor is not given here. The quotient and remainder were x minus 2 and minus 2x plus 4 respectively. Respectively means quotient is x minus 2 and remainder is minus 2x plus 4. So what will you do first? You should subtract remainder from dividend. This is what we are doing here. Dividend minus remainder. Okay. You will get the answer as x cube minus 3x square plus x plus 2. Okay. Then you are dividing this answer by the quotient x minus 2. Now for finding g of x, we will divide x cube minus 3x square plus x plus 2 with x minus 2. Same division algorithm, you will get the answer as x square minus x plus 1. G of x is equal to x square minus x plus 1. Next one. Give examples of polynomials p of x, g of x, q of x and r of x which satisfy the division algorithm. So this is the explanation of division algorithm. The first question is degree of p of x is equal to degree of q of x. P of x is the dividend, q of x is the quotient. So degree of the dividend should be equal to degree of the quotient. There is only one condition, only when the divisor is a constant term. Degree of dividend is equal to degree of quotient only when the divisor is a constant term. Clear? So how will you write an example? You can write a polynomial and divide it by a constant. So you will get the quotient with degree which is equal to its dividend. Clear? So in this question what you should learn is degree of dividend is equal to degree of quotient only when the divisor is a constant term. Here degree of q of x is equal to degree of r of x, that is degree of quotient is equal to degree of remainder. This is possible when degree of quotient and degree of remainder should be less than p of x and g of x. Here we have written an example. Degree of r of x is 0. Degree of the remainder is 0. When is degree of remainder 0? The degree of the remainder 0 is only when the remainder left after division algorithm is a constant. So this is the example.